introduction. For those of you who were here for the last talk, the speaker had a very cool introduction with him shooting long-range sniper rifles and whatnot. I have one boring slide, and I work for IBM, so not Apple or some other company. And this is being recorded, right? I should delete that part. So my name is Sanjeev Sharma. My background, I'm a solution architect. I go to customers and help them design software development platforms. So I don't actually design the applications for them, but help them create software development platforms on which to build their entire software delivery lifecycle, whether it is a large air defense system, or whether it is a mobile app, or whether it is a standard IT application. And one of the things I've been hearing about a lot and seeing a lot of customers struggle with is DevOps. So, and more specifically, which is I guess of context here in this for this conference, is mobile DevOps. That's why I decided to. Speaking at tablet, that's me. My alarm also went off, telling me I should be speaking now. So that is the context of here. I have a blog. You're more than welcome to visit it, where I blog about design, about mobile, about DevOps, about agile transformation. Whatever I interact with my customers and learn, I share through my blog and my Twitter feed. So you're more than welcome to visit it. And I've been in the industry for more than 18 years, as mostly working with in the software development field. And I'll be putting up these slides on my blog, and I also plan to record a YouTube video around this, going into more specifics than I can in a 20-25 minute presentation that I'm going to have today. So what is DevOps? Who's familiar with DevOps? Who's heard the buzzword, right? So DevOps is, like all these buzzwords which come up over the years. When it comes up, everybody talks about it, but most people don't really know what it is, and the definition really varies from company to company and from consultant to consultant, and nowadays from blog to blog. So what I wanted to do was, before I jump into what our best practices or recommendations are for mobile DevOps, is to talk about what is DevOps, right? So if you look at DevOps, right, it is a space of challenge which customers, which developers have discovered as they work in an agile development manner. So everybody here familiar with agile development, right? I mean, you should be, right, in today's day and age, right? What agile did was it addressed what we are referring to here as the first gap, which is the gap between the customer and the developer, or the gap between the user and the developer. What it did was it introduced ideas like continuous integration, continuous delivery, short sprints, having an executable at the end of every sprint, so that we could interact better with the customer, or if you were an enterprise, with a business user, and show them what you're developing. But it did not address the second gap, which was the gap between the development team and the operations team. With Agile, what is the development team trying to do? It is trying to disrupt. They're trying to bring out as many new releases and features as possible. 1 week sprint, daily integrations. Now, what does an operations team want to do? Stability. What happens to when an operations team, what does an operations team not want? It does not want downtime. It does not want to be on the front page of the local paper, or the front page of the internal newsletter, or be on the radar of the executive saying that, our customers can't get to our application. So these are two conflicting goals which these two teams have. The whole idea of DevOps was to bridge that gap, to bring them closer to each other, to bring development and operations on the same page, while agreeing to disagree on what their disparate challenges and their disparate goals were. So that's what DevOps did. And what it did was, the idea here was to reduce risk by having continuous feedback between the development teams and the operations teams. So let's just delve into that deeper, right? So what happens? So let's look at this slide, and this kind of explains what happens from both sides' perspective. So I am a developer. I work in an agile team. I have continuous integration. Every time, every day, I make a build and I integrate it. So you have the CI queue piling up, and you have all these continuous integration builds sitting out there. But if my operations people are not able to supply or provision the environments on which I can deploy those continuous integration builds, on which I can even test those continuous integration builds, I'm running into a big gap there. I'm running into this backlog of continuous integration builds, and I have this funnel where I might be building 20 CI builds, but the operations teams, they say they can only handle 1 a week because they cannot provision the environments as I want them, as I need them for my integration, for my test, and for my integration of integrations if I have multiple teams. We call this phenomena water scrum fall. You're doing scrum, but at the end of it, there's a big gap, right? Because the operations team still wants to operate in the waterfall mode. Now let me put on my operations hat, and I'm going, look at all these builds, all these continuation integration builds. 80% of them are useless. They'll crash my machine. They don't even compile. When I try to run them, they crash my server. They create load spikes. They create all these processes. So they have this issue of, this guy, you see, pulling his hair out. They're going, what are all these builds for? Why can't they have better quality? Can I have some kind of a semblance of quality control and some kind of process behind all these continuous integration builds which are being created out there, and what ends up on my machine, on my server, on my environment without destroying them? So these two conflicts are what DevOps tries to address. So what is DevOps? In simple terms, it is a movement right now which introduces certain principles and practices which are amenable to both the needs of developers in an agile environment and of the operations side who want stability but want to support the agile practices like continuous integration, continuous delivery. So there are 3 key principles of DevOps, right? And here's a pop quiz for everybody. This hand being shown out there showing 3, why is that the hand of somebody from Germany? And there's some of you who've seen a movie out there who can answer that question, and those of you who've not seen the Inglourious Bastards can't answer that question, right? So go watch that movie, you'll know why that's a German hand. So 3 principles. Number 1, develop and test against a production-like system. This is the first principle of DevOps, is that do not develop and test against your laptop or desktop which has no semblance to reality. Now, note it doesn't say go test in a production system because you'll keep bringing it down, but a production-like system. So from a developer's perspective, when I have a continuous integration build, what it gives me is a real build, a build which will, in an environment which is very much like my production environment, so I can have some kind of trust in the build that if it works in this production-like environment, it will work and function and perform the same way in the real environment. For the operations person, what this says is that I don't have to let people in to my production environment. I can create a production-like environment, a test or a staging area where they can do their builds and do their testing. Number 2, deploy frequently, preferably daily. You can read up, go Google the term no-ops, and there was this whole thinking at Netflix where they wanted no-ops, where they said every time the developer says check in, it should result in a continuous integration, even if it is 100 times a day, into a continuous integration build being kicked off, leading to a continuous deploy build. And of course, that's not possible in most scenarios, but frequently, as frequently as possible. And the third principle is to continuously validate the operational quality characteristics. So in your test area, you want to validate, does your application function as designed? Does it perform as designed? Then in your staging area, again, validate whether your application functions as designed and performs as designed. And most importantly, once it's deployed, have monitoring tools, have monitoring hooks built into your application, especially a mobile app, which allows you to validate that it is functioning and performing properly. So these are the key principles, what we call the 3 big pillars of DevOps. And in the rest of my presentation, I'm going to develop on what I call the 10 best practices of mobile DevOps, which are basically based on these 3 principles. Any questions so far? Feel free to interrupt me. My presentation has enough time to answer any questions. Yes, sir. Yes, so functionally and performance-wise, both. So if you have any...
This is the checklist of what you're supposed to look for to make sure that things are working right.
Exactly. So both from a functional perspective and from a performance perspective. So if you have any performance SLAs, is it performing within those performance SLAs? So now let's jump into mobile DevOps, right? Mobile is interesting, right? It creates, and we've been hearing about it all along, right? And there are certain characteristics of mobile app development which make it more challenging than traditional DevOps. If you're building a traditional enterprise application, right, you will have different DevOps challenges. And I have a few slides at the end which I'll go into if I have time about traditional enterprise DevOps. But mobile brings to the table certain different challenges. Number one, fragmented platforms. Android is heavily fragmented, right? There's a separate Android for Kindle, separate Android for Nook, separate, and the Android on Nexus 7 is different from Android. iOS is also forked now. There is iOS for iPad, there is iOS for iPhone, and now with the new iPhone 5, for every app you built, you will have to query the hardware to find out whether it's an iOS 5 because its dimensions are different. So you're going to have that additional step of either building a separate app or an app with a different resolution just because you wanted to allow in full screen mode on an iOS 5 because the resolution of the screen is different. Now we can build, say, hey, I don't have to support all these platforms. I'll build an HTML5 Cordova PhoneGap app, but you can talk to, I think there's a session either going on right now, is here right after me. There are challenges. Andy Glover is going to be doing that session. There are challenges with HTML5 and Cordova. There are certain apps, device-specific capabilities which you're not going to have. Facebook is a great example. They actually dropped their HTML5 on iOS, the HTML5 app, and switched to a native app because they were not getting the performance on the HTML5 app which they wanted. Now they're going to go back, at least that's what their blog says, but as of today, they went to a native app. Mobile apps, especially if you're building a complex app, you're not building Angry Birds, which is complex, but you know what I mean, right? You're building it. Really, your app ends up being a front end to a whole assortment of either enterprise app or other APIs served up from third parties. So when you talk about DevOps, you're not just talking about your app. You're talking about the DevOps of the entire ecosystem you have built, whether it is your own internal enterprises applications which you are accessing from your mobile app, or whether it is third-party APIs which you're accessing. And last but not the least, the whole idea of continuous integration, continuous deployment is I push a button and the app gets deployed to a production-like system. Well, in most mobile app environments, and all actually, you got this thing called the App Store in between, whether you call it Google Play or App Store or App World, which is the asynchronous step. If you have a bug fix, you send it to Apple, it's a new version, you still got to wait as many days as Apple thinks you ought to wait before it gets released. Not very effective, which is why that whole idea of production-like system testing becomes very important. Do you have an app store where you can test, an internal app store? And we'll talk about that. So these are some of the challenges based on which we've based our best practices. And here is an example of a typical enterprise-based application, mobile application. This is LinkedIn's architecture. I got it from their engineering blog. In the first vertical column, you have an iOS app, which is actually a hybrid app. It's got iOS controls, but embedded in it is basically a web view running HTML5 and JavaScript. Their Android app is all native. Their mobile web app is obviously JavaScript and HTML5, and others for BlackBerry and all are all wrappers put against their HTML5 and JavaScript apps. So they have to build all these 4 pillars simultaneously, release them simultaneously, and build and debug them simultaneously and test them simultaneously. But what it is sitting on is a REST API layer made up of Node.js, which is, by the way, an excellent implementation of Node.js. There's a great article on how they can get it to perform so fast. But all of this is really nothing but a front end to their enterprise LinkedIn architecture. Note in this slide, they don't even talk about it. To them, it's a black box. To the mobile development team, the enterprise, the actual LinkedIn application, which we all love so dearly, which we access through our web browser, to the mobile guys, it's a black box. They're just talking to it via a REST API. So this is a typical mobile development environment, and this is the kind of applications which we are talking about when we talk about addressing these challenges. Any questions so far? This is kind of my introduction. Now I'm going into the actual best practices. So here are my 10 mobile DevOps best practices. Number 1. You have animations. Come on. I built this on a Windows box. It doesn't translate very well to iOS. Number 1, have a common team repository and version control all artifacts. Now the key word here is all, not just your code. your deployment scripts, your test scripts, your requirements documents, your anything you have, your diagrams, your wireframes, whatever you have assets you have associated with your mobile app development, version control it and have a single central repository. So if you're a distributed team, each developer using their own Git repository, that's not it. It's only going to add more complexity if you want to have those synchronous, continuous integration, continuous delivery. Get a professional, either free like Subversion or a professional one like, Team Concert or whatever. I don't want to throw out product names here, but there's a whole bunch of them. Get something which can give you a central repository either on your own server or somewhere in the cloud, where you can have a common source of truth accessible to all the stakeholders across all your teams, where people can know these are the versions of assets which I'm working against. That is how you can build a truly synchronous team of teams delivery pipeline for your continuous integration, continuous delivery builds. Number 2, practice continuous integration. It is the prerequisite of having an agile development environment. But that continuous integration is the only thing which will lead to continuous delivery, which is what DevOps is all about. So if you have multiple teams, have all the developers submit their code at least once a day and do an integration build. And once a day or maybe once a week, whatever timeline works for you, have the teams submit their work together to do a continuous integration build for the entire application. If you go back to the LinkedIn architecture, and they talk about it on their blog post, they have an iOS team, they have an Android team, they have a JavaScript HTML5 team. Each team has its own private, each developer has his own private build. Each team has their own integration build. And then the team of teams for the LinkedIn mobile architecture have their build for the entire architecture. This is what guarantees that what you produce is in sync with each other, so the Android app doesn't go off on a tangent as opposed to the iOS app. Any questions so far? And for these, you have to make sure that your integration and production and private build servers are as identical to each other as possible, and as close to the build environment and deployment environment which you're going to finally deploy to as possible. Number 3, as we've already heard, there are multiple SDKs, APKs out there. Keep separate areas in your development environments, and if you are using some kind of a standard IDEs, those IDEs are going to allow it ability to I went back too much, sorry about that. Have the ability to create separate folders, to create isolated areas for each one of your SDK versions. And if you've done any Android development, you can query, you have to put in the code to query what SDK version, what Android version your application is going to be running on. Well, ideally, instead of having, if you can build something where it's common and it can run across all your SDK versions which you're supporting, that's great. You can query it and find out. But if you cannot and you have to separate code bases, keep them isolated. But at the same time, have your branching and merging application of your source code figured out so that you don't have them forking and branching away from each other. So if you have a bug fix, you can deliver the bug fixes to all the different versions of the application which you're supporting. Any questions so far? Any making sense? Great. Number 4. Yes, sir.
Yeah, actually, the way I've been doing it so far with my iOS development is in Xcode, you actually can test against different simulators and then test against the different handhelds. But that's all still one basic repository.
Right.
The way you're talking about, you're creating a different build for each
SDK version. So this is not
SDK and
right.
each device being tested against. So that can get complicated, but it actually, it's a different paradigm. It sounds kind of hard.
Right. Are you building only iOS apps?
Right now, yes.
Yes, so that's why you're not facing the challenge. If you're building iOS app and you're supporting 3 versions of Android,
So
Kindle,
you're
exactly.
talking about different versions of SDKs, you're talking about different platforms.
Right, and even for different versions of SDK, it will remain the same. You won't have as much of a challenge as those SDKs have not diverged so much from each other. But as iOS grows, maybe as you go to iOS 6 and 7, you will see you'll want to drop support for the 3GS device because the 3GS device is still there. So let's say version iPhone 3, I believe, cannot be upgraded to iOS 5. So now you have to make sure your code base, if you want it to run on iOS 4, is going to be very different from iOS 5 and 6 and so forth. It is when you start having non-supported devices which you need to support, which are not supported by the current SDK, when you run into this problem. As long as the current SDK you're using supports all the devices you want to support, you won't have that problem. It's when and you'll see that today with Android. A Kindle is very different, SDK is very different from a Nexus SDK. So it's ideal to keep it separate. On iOS, we haven't faced that yet, but we will soon, right? Any other question? Yes, sir.
Actually, and this may be a little premature question, but I haven't seen the rest of the points. But just I'm more from the management side of things, or the project management side of things. But just based on your first 3 points, what is your recommendation, or what is your experience in terms of justifying the overhead that goes into all of that?
Well, the question for those of you might not have, what is the justification of all this overhead you're creating? If you're it's a standalone small app which you're going to sell in the store, right, and you are 2 developers, yes, the overhead is not justified. But if you're an enterprise, and to you, the quality of your app and making sure the user experience remains the same across all apps, and the quality remains the same across all versions of the apps which you're going to support across all devices, will justify the overhead. Because you don't want somebody to have a different experience if they're using a device which is different from your gold standard device, right? That's where you'll see the overhead. And we can have a conversation offline, about what the justification is. But I'm running out of time here. So automate your build and deploy scripts, right? Today, if you're building and deploying, again, this is not as much as a case for something like iOS, where Xcode does a lot of this for you. You'll see this more in Android development, or development for a Windows app with Visual Studio, that there are build and deploy scripts. Automate them as much as possible, right? If you want to use a tool which does that automation, go ahead and use it, but automate it and version those scripts, because your scripts will also vary with different versions of the application and the SDK and the platform you're supporting. Test each build. Well, goes without saying, right? Test each build not just on the emulator, but as far as possible on a physical device also. Any developer, I can tell you myself that sometimes things work very differently on the emulator than they do on the physical device. And the person before me who was from BlackBerry was talking about the same thing. They created the Dev Alpha device just for that very reason. You cannot guarantee that the application will perform the same on an emulator as it will perform on the actual device. So test it on both. End-to-end testing. This is a very critical area, and I put in a brief pitch for my company. At IBM, we spend a lot of time addressing this. If your application is anything what you've seen here on the right here, where it is really an endpoint and it is communicating to several enterprise applications, several APIs, you might not have access to all those enterprise applications and APIs every time you want to do a test. Some of those APIs might be paid pay-per-use. You don't want to be paying for them if you're running hundreds of tests every day. So stub out those APIs and use some kind of a simulation software to emulate those APIs and so that you can test the behavior, whether you have to pay for the APIs, that way you'll be saving all the money. If it's on a mainframe, you'll be saving CPU cycles. If that API is not yet ready because a third-party system has not even been built, you can still test against it, right? So that is the whole thinking behind this, right? And the diagram on the left here shows that in the beginning, your app might be ready and maybe only one API is available. Emulate the rest. Build an emulation or virtualization, virtual simulation of the rest of the APIs so that you can test the behavior and test your application interacting with them, even though they're not available to you, either due to their unavailability or due to their cost. But do end-to-end testing. Number 7, this becomes, again, is an issue. If you are 2 developers, you can keep your keys in a folder on a jump drive, all the API keys, all the provisioning code you have, the one which Apple gives you, one which BlackBerry gives you. But if you're a large enterprise, you don't want to have too many of these floating around. You want to have a central governing mechanism with version control of all the provisioning, provider provisioning profile, the certificates, all the API keys you have, or whichever API you're using. And nowadays, APIs are becoming, everybody has an API, right? You go to I think it's called Mashable.com, or you're going to go to IBM's Cast Iron. These are API servers. These are API management companies who manage all these APIs for you. You need to have, each one of them gives you a key. That's the first thing which happens when you go want to use an API. They give you a key. You have to be able to manage them centrally. Number 8, and this we talked about earlier also, monitor the deployed app and back-end service performance. Build in hooks into your application to monitor its performance. Build in hooks into your back-end service providers. Excuse me, whether it is your own enterprise app or it is third-party applications, to make sure they are performing well. Well, how many times have you gone to a web page and it's hanging on Twitter not loading? Right? You can see at the bottom it's waiting for Google to load or the Twitter API to load. Well, that happens to your mobile apps too. The performance might be slowed down because of some third-party API or third-party call which you're making, which is not responding as you would like it to. You want to know that. You don't want your users giving you a 1 star because some third-party API doesn't perform the way you want it to or the way their SLA said it would. So put in hooks into your application to monitor that. And there are several vendors out there who have solutions for that. Number 9, and this I talked about earlier also, have a virtual app store. I know IBM has one through their Worklight tool. App 47 people have one. So that you can test the actual deploying of the application from an app store. How does a user get an application? They don't get it the way you get it as a developer, side-loading it onto your device. They get it through the app store. Do you test that? Or is the test when Apple loads it into the app store and you try to download it yourself and it fails? Or doesn't download the way you want it to? Well, test that. That's a very significant part of end-to-end testing. And there are enough virtual app stores or enterprise app stores available out there that you can include that in your testing. And last but not the least, track all the feedback you get. Don't be like this cartoon, right? Turns out people aren't buying our apps because they're stupid, right? But obviously, hopefully your app did some research and your app is good. But what is the feedback you're getting from your users? What is the feedback that you're getting from your testers, especially your users? How many of you have ever gone back to the App Store and left a review? Okay, that's around, well, I guess we are all developers, so we do it. But, Joe user doesn't do that, right? But I only go back and leave a review when I hate the app. I rarely leave a review when I have certain issues with the app, right? But there are people who might have a minor problem with the app. Do you have a good feedback mechanism? I love the new, how many of you got the new PayPal Here app? That device to swipe credit cards like a Square. It's PayPal's answer to Square. Right at the bottom of the app, it says shake for help. And if you shake your device, the help page comes up. I thought that was awesome. Because right from there, they get feedback. Every time I shake, first of all, they come to know, this guy shook the app. Then they want to know what I was doing. They're getting feedback right there. And there are their enhancement requests, their change requests, and the user stories on how to enhance their application. So build some kind of a mechanism to track that. First of all, to get that from the user and then track that. So those are my 10 best practices for DevOps, for mobile DevOps specifically. I have a few more slides in here, which are in interest of time. I'm going to skip. There are more to do with DevOps for the entire ecosystem, because as I said, your mobile application is really a part of an ecosystem. It's a front end to your back end. I'm going to post these slides on my blog, sdarchitect.wordpress.com. Feel free to go there and download them. And any questions? Yes?
So you didn't talk too much about testing, like issue tracking, to linking issues to builds, to, I don't know how to explain it, but
right.
essentially
right.
traceability all the way from testing back to check-ins.
Yeah, actually, it was on my end-to-end testing slide. I must have not forgotten to mention it.
Okay.
But the whole idea of end-to-end testing is that when you do end-to-end testing and you find a defect, you have a mechanism to get it back to the developers. Have that traceability so that developers know where the tests failed. Hopefully have an automated system to create defects which track back to the work items the developers were working on. I don't want to focus too much on that, because to me that is more of agile development practices than DevOps practices, right? We are assuming here that you're all doing good agile development. There are tons of books out there. Scott Ambler just came out with a great book called Disciplined Agile Delivery. Make a plug for that book, which is basically agile, how to apply agile to enterprise application development. So, books like that and agile practices talk about having that end-to-end traceability. But that's a very valid point. If you have to have that traceability for this all to start. The focus out here was more to focus on the operations end. But good point. Any other question? Yes.
Are there specific tools? I'm familiar with the agile software engineering stuff, and traditional enterprise development using Agile and software engineering, there's tools coming out the wazoo to support all of this stuff. Are there any tools that are out there that support DevOps, Agile engineering that are built specifically for the mobile environment?
I work for IBM, and we have a tool called Worklight. So I have to talk about that. I'm sure there are others also. Yeah. The Worklight IDE is free. So it's a cross-platform HTML5 Cordova-based IDE. It's the only IDE that I'm aware of out there which allows you to do iOS development on a Windows box. You eventually need to put stuff in Xcode. But it has something called a Worklight server, which supports a lot of these notions of mobile DevOps. It also has a virtual and an enterprise app store. So a lot of these capabilities are supported out of that, but I would highly recommend you check that out. I'm sure there are others out there also which I'm not too familiar with.
Is that equivalent to Hudson Jenkins?
No, Hudson and Jenkins are more for build and continuous integration automation.
Okay.
So you would still need those for your enterprise side, but it can handle some of the capabilities within the mobile application side. So it can do the build and continuous integration for mobile applications. So if you go to the Worklight page on IBM side, there's some very nice papers on how to implement continuous integration with Worklight. Again, I don't want this to turn into a marketing pitch for IBM, but generic questions, please. Anything else? Great, that took my time. Thank you for your time. If you have any questions, I'm around for the rest of the day, and SD_architect is my Twitter handle, and I already told you my blog. Thank you.